Okay, good evening, ladies and gentlemen. Okay, today's topic is about battery technologies. Okay. So first, I will give you an overview of on the battery classifications, and then a short introduction about the battery principles. Then we are talking about batteries. So of course, battery is for energy storage, but there are other technology for energy storage other than batteries. For example, like using a dam, a water storage. You store the water in the high ground, and then later, when you need the energy, you release the water, you turn the turbine, or you can use a centrifugal force, or you can use liquid nitrogen, you can use air pressure, all kinds. Those are energy storage options. They are not exactly batteries. Here, batteries we talk about are those with chemical reaction, those batteries. The other one, like supercapacitor, is also one form of energy storage, but we are not discussing that. We are just, for this talk, we purely talk on batteries. Okay, then we will open for discussion, then you can ask any question. Okay, this is my own classification. Okay, so I classify them as portable, which you can carry around. Transportable means you can put a vehicle and drive around. And then a fixed one is because it's too heavy, you normally don't want to move it around. Just fix it in one location. Okay. So the principle for batteries is very simple. They normally has three items, anode, cathode, and electrolyte. It is just a name, they call it anode. Okay, scientists like to give name to everything. So anode means a negative electrode. They can simply call it negative electrode, but they call it anode. Better, just like instead of a description, they give a name. So when talk cathode, they know it's a positive electrode. But after some time, you don't know what's anode, what's cathode, which side is anode, which side is cathode. But positive, negative, you know. You look at the battery, you know where's a positive, where's a negative, because there's a plus sign and a minus sign. But there's no sign for anode. And then electrolyte is a chemical that is in between, so that it can conduct ions. Ions are charged particles. Atoms are charged atoms or molecules that move between the anode and cathode, that give you the electric flow. Of course, in some batteries, there's something in between they call separator. Okay, that one is not discussed here. Basically, there are three things, anode, cathode, and electrolyte. Okay. So portable batteries are actually, they must be very small enough to put in your pocket or just in a small bag and carry around. Some common ones are AAA, you know, right? AAA, AA. Okay, sometimes AA, if you go to AliExpress to buy, they will put it as 14500. So 14 stands for 14 mm diameter. 500 stands for 5 cm. Okay, that means 50 mm, 50.0 mm. And then for these two are the common one, AA and AAA. So the bigger one they call C cell. Then even the bigger even bigger ones are called D. But nowadays is very difficult, not easy to find. There's very few people who use even C or D, because in the past, when they need more energy, like in torchlight, they use a C cell or D cell. But now they will use lithium battery, and the torchlight don't consume a lot of power, or they use a LED torchlight, so the battery don't need to be very big. So those battery will be obsolete. In fact, those AA and AAA, those batteries, one day you will be obsolete already, because they are too expensive to use. You buy one pack, maybe one pack of heavy duty, $1 for 4 pieces. But if you keep using it, it becomes more expensive, because lithium has become very cheap and you can charge many times. So if you own a battery company, you better switch to lithium or something else. Okay, then there's other very common, it's 18650. This is a common battery that you can find in your laptop and power bank and a lot lah. Last time Chan Han was introducing one piece $2 ni. He bought from China, so it's quite cheap, and $2, and you can power up everything. Those are 3.7 volt. And then you have others like coin battery, CR2016. This one means 20 mm diameter, then 1.6 mm thick. So this look like coin. Okay, and then if you get CR2032, then means it's 20 mm diameter and then 3.2 mm thickness. Okay. Okay, so very common. This one, dry cell, we call it dry cell. Okay, this type can be heavy duty or alkaline. Okay, but they are not wet. They are dry because it is like gel. They have some liquid inside, so it's moist. It's a little bit moist, so that you can conduct electricity. It's not fully solid, because if it's solid, then nothing can flow. The ion cannot flow already. So it's some quite gel, but it's a little bit moist. So, and then you won't leak. You top it upside down, it still work. So you don't care which direction. You can place it any direction, it work. And they are all 1.5 volt. Normal operating voltage. Then you have the nickel cadmium type, which is 1.2 rechargeable. This one has a memory effect. Means every time you discharge a bit, then you charge. You discharge a bit and then you charge again. So after a while, you remember already. So then you lose your power and you remember the little bit discharge one as the base, and then your battery cannot operate anymore. You get worse. So no, but very few people use this thing. Some are still use old technology because it can be cheaper. They put this on the emergency light, where when the power failure, then the light turn on. So sometimes they use a nickel cadmium battery, very old technology. But at home, very few people use. I have some of these batteries. I don't even want to use, because 1.2 volt, and then if you use 2 pieces, it's 2.4 volt, and the device expected 3 volt. When you put it in, after a while, they tell you battery low. So for some devices that can operate down to 2 volt is okay, but some just cannot. Okay, and then a better one than nickel cadmium is the nickel metal halide. This is 1.2 volt. In the early years, they used this for cameras. Because when you use a flash, if you use an alkaline battery, you flash 30 times, gone already. Cannot, no more charge. But this one, you can go maybe until 60 times. But if you use lithium, lithium can flash out or 100 over times. You know better, more energy. And it has a higher voltage also, 3.7 volt. So this nickel metal halide will also be obsolete. Is getting less popular nowadays. And all these are like AA and AAA type. So when it comes to lithium, lithium has the main problem with lithium is that it's 3.7 volt. It's not 1.5 volt. So it cannot be used as a direct replacement for your existing battery. But then soon, even if you go to China, a lot of devices like toys, all this, or fan, let's say you have a portable fan that want to blow your own self, you look at it, it's either USB, plug to USB power bank, or they have a lithium ion battery inside, 3.7 volt. You just put one piece only, and then you run the fan. So it's very popular nowadays. Instead of using AA and AAA, two pieces of it, they put one lithium ion. And then if it's flat, they can take out and recharge. They don't need to buy again. And it's very cheap. One battery, lithium ion battery, is only $2. So it's very affordable. And then the next type of lithium is called lithium iron phosphate. It's 3.2 volt. Okay, Li is lithium, Fe is ferrous. Ferrous material means iron. And then P is phosphorus, O is oxygen, four oxygen atoms. So they call phosphate. This one is 3.2 volt. It's also lithium, but this one is better in the sense it won't catch fire. Just like lithium ion, it will easily catch fire. But lithium ion is very popular in a handphone because it has a higher voltage and it can store more energy. The other type of lithium is not so popular is lithium titanate. It's 2.4 volt because it's in between alkaline battery and the lithium battery. So it's in the odd voltage. So this one, there's one big factory that's doing it, specializing in this lithium titanate. This one has a potential, but currently it's expensive. Okay, so you look at more battery. This one coin battery, okay, alkaline battery. They have this code like LR41, 43, all kinds of numbers. It's very confusing. This type of notation is easier. Like CR2025 means 20 mm diameter, 2.5 mm thickness. And then you have a zinc air battery. This one, zinc air battery is 1.35 volt. Okay, zinc air is very popular for my very tiny devices like earpiece, hearing aids. Because they don't want the hearing aids to be seen. Some people want beauty. They see a hearing aid and be, hey, what's wrong with you? So people don't want to put these hearing aids. So they want it invisible. But then if you put a earphone, big earphone, cover a whole ear. Okay, people thought it's earphone. Once you put a hearing aid, then people think hearing aid. But nowadays you can fashion your hearing aid like Apple iPod, the earphone. So people will think that you are trendy. It's not a. Okay, they'll see that you are trendy and not having hearing problem. So that type bigger, you can put other battery like lithium battery. Zinc air battery is very light and it has a lot of energy, like twice that of a lithium battery, because it uses oxygen to oxidize the zinc to produce the power. Okay, and you don't have to carry oxygen. What oxygen comes from the air, so it is much lighter. Okay, you may think that oxygen is very light because it comes from air, but oxygen has weight, just like iron oxide and iron. So iron oxide is actually heavier than iron. So when a piece of iron rusts, you get iron oxide, and if you weigh it, it's actually heavier than iron, than the original weight. So if you don't carry the oxygen you take from air, your battery becomes lighter. The only downside is zinc air cannot be recharged. And normally these type of coin batteries are not rechargeable. Nobody recharge it because it's not designed for recharging. And then some of the battery shapes you can see is a flat pack. It comes flat pieces. These are popular in notebook or in phone especially. Okay, and you can buy this type of flat pack battery and then put in your device. If you don't have space, this become quite useful. Okay, now we go to the lithium ion battery, 3.7 volt. Okay, normally they call it 18650. This size of the battery, the dimension. Okay, based on this dimension, you won't know is it lithium ion or lithium ion or lithium iron. The two sound like iron and ion. Okay, but it's just a dimension. Most of the time is replaceable. You can use either lithium ion or lithium iron. Okay, the full name is lithium iron phosphate because the difference is 3.7 and 3.2 volt. So a lot of devices will be able to absorb that small difference in voltage. Okay, and sometimes they put this lithium ion battery, okay, they pack it up. Okay, 4 pieces, 8 pieces, whatever pieces they just pack it up and solder together. But what you cannot see here is actually electronic load balancer. Okay, without this load balancer, you cannot charge the battery. The battery will overcharge because if you put them in series, then you have a problem. When one battery is full, the other battery is not full, then you get into problem. So the one that is full and then you continue to charge, then you can damage the battery. Then the one is not full, cannot be charged. So you need a balancer, which the electronics will bypass the battery that is already fully charged. And then you go to charge the subsequent ones. So the electronics will control. So you look at this, if you want to use the battery in yourself, you cannot put them in series like that and use. Use can in series, but when you want to charge, you cannot. You must have a load balancer. Okay. Every of these have a load balancer. You can't see only. Okay, then lithium iron phosphate, okay, is 3.2 volt. Okay, this one is 18650, which is the same size as a lithium ion. And you have another type is 26650, is 26 mm diameter, is fatter. These are very common in storage battery, like those type that you see here. Where they connect them in one whole array of batteries. It can be series or parallel depending on how many volt you want, how much current you need. So there are some parameters and some requirements. Okay, the only problem with this lithium iron phosphate and lithium ion battery in, let's say, a battery pack is the voltage difference. Let's say you want a 12 volt battery. So normally they use 4 pieces. So if they use 4 pieces of lithium iron phosphate battery, then you take 3.2 times 4, okay, will get you 12.8 volt for lithium iron phosphate. But if you use lithium ion, it's 3.7 times 4. So the voltage will be higher. So that is a difference. So this difference is not much for 12 volt. So normally people can ignore. Sometimes they can even use this to replace the lead acid battery. Okay, which I did not show here. Lead acid battery is the lead acid battery. Sometimes that people call AGM battery, which is something like lead acid, except that the acid in this case is a gel. So it will not flow left, flow right, and then you can turn it upside down. It will still work. So this is just improvement in the electrolyte, but basically the anode cathode are all using lead, so it's very heavy. Okay, so 12 volt you may not notice the difference, so it's quite okay for 12 volt. But once you go to 24 volt, then you have a problem already, because 3.2 times 24, no, 3.2 times 8. Normally they put 8. Okay, then the 3.7 times 8 and 3.2 times 8. So there's a difference of 0.5. 0.5 times 8, 4 volt. Oh, can be quite risky already. Okay, but generally people still use, they also treat them like a 24 volt battery. Then when it comes to 48 volt, normally you take a lead acid battery or AGM battery or deep cycle battery. All these are lead acid battery. You need 48 volt. They will take the 12 volt. They put 4 pieces of 12 volt together. Then they get 48 volt. Okay, but in lithium battery, you normally should not connect them in series. Okay, lithium batteries are not supposed to be connected in series. But if you want to connect them in series, can just connect them in series to use it. You cannot connect them in series to charge. You will have problem. So if you need 48 volt, you cannot connect 4 of these lithium battery pack, 12 volt each, put them together in series and charge. You will get into problem, because when one of the battery is weak, then this battery cannot be fully charged, and it will remain not fully charged forever. It's just like you put 4 people on a table, and then you provide the food. The stronger one will always eat most of the food. The weak one will always lose out on the food. So every time the weak one will be hungry, the strong one will be very full and always overeat. And for lead acid battery is okay. If when the one that's full, he can't eat already. So it will just the weaker one will have chance to eat. But for lithium battery, because they have electronics inside. Okay, all this battery, when you look at it, it looks like just like ordinary battery, but inside there's the electronics. So when it is fully charged, it will cut off its own circuit. So it will not let you charge anymore. Because if you continue to charge, you will damage the battery. So when it's fully charged, it cut off. So once it cut off, the other batteries in series will not get charged. It's the same like you got 4 people on the table. The person who finished eating, full already, he will stop all the food from coming in, clear all the food, no more food. So the one who eats slow will not have food. So that battery will not be charged. So over time, 1 time, 2 times, 3 times, and this battery get weaker and weaker and weaker and weaker. And then your whole circuit, your 4 battery is the sum of all the 4 voltage, will not be enough to power your electronics. So this is a problem with lithium battery. Never put 4 batteries or batteries in series, especially when you charge them. Okay, unless you charge them in parallel, then it's okay, because that means you serve 4 tables. Each one table you serve. Cannot, you full already, you don't eat. Okay, the rest continue to eat. But you put them in series, no. So what to do if you want, let's say 48 volt, then you must buy a battery pack that is already 48 volt. 1 battery pack that's 48 volt, because built in there is a battery balancer that will balance out all the charges for the batteries internally to get 48 volt. If you want 24 volt, you must get 1 battery pack that is exactly 24 volt. Don't get 2 12 volt and connect them. You won't work, it won't work. It's not advisable, not say it won't work, it's not advisable. So, and the problem comes with 48 volt. Because for 48 volt, you can use, for 12 volt is 4 battery. Okay, 24 volt is 8 battery. 48 volt is 16 batteries. Okay, but sometimes you put 15, you still get 48 volt. But you put 16, it's actually 50, 52 volt like that. So it's actually much more. So you put, some put 15, some put 16, and then you have a problem already. So when you want to buy a 48 volt battery, you must make sure you know what is the voltage or how many cells are inside there, whether 15 or 16. Normally they are 16, but some cloud will put 15 because to make it compatible with the lead acid battery and the gel battery. So they put 15. So you got 1 battery short. And you want to charge this, you thought it's 16 battery, you put a different voltage, you charge, then you can damage it. So this one you have to be very careful. And for 48 volt, you also have to be careful, because if you touch the battery, you can get a shock. And it may not kill you, because 48 volt won't kill you, but you can get a shock. That's all. So just wake up. If you are sleepy, just touch it and then you wake you up. Okay, this one is lithium titanate. This ink long is very popular. It seems like they are the only supplier. So far, you search lithium titanate, every time you see this ink long battery. It's very big, it's very big. They call it xxxxxx. It's 66 mm and 160 mm. It's not 16.0 mm. In this case, it's 160 mm long. It's very big size, almost like a water bottle already. And this one is 2.4 volt. Okay, or sometimes they put 2.3 volt. Is around there. Then they come with 2 screw thread. So you tighten, put your wire inside, tighten it. Okay, you cannot tighten too much. You don't tighten until very tight, because you overturn the screw and the electrode connector get separated. Inside is a very thin wire holding all the electrodes together. And then they mount it to a screw. So if you turn too hard, then you break the electrode and then your battery get disconnected, spoil already. So, and the good thing about lithium titanate is that it will never explode. You can drill a hole into it and it will not explode. It will not burn. It's very fantastic. Okay, so this lithium titanate, the nominal voltage is 2.3 volt. So that's why it's normally not found in electronic devices, because all these the market has been captured by the lithium-ion battery, which is 3.7 volt. Okay, or the AA, the old alkaline battery, 1.5 volt. So they put two. Normally battery you always put two pieces, so it's 3 volt. But 2.3, a bit out of location, so nobody use. So this become a very niche market. Lithium titanium is normally used only in a battery pack. If you want to build a battery pack, let's say 48 volt, 24 volt, a huge battery pack, which is, let's say, 40 kg battery pack, then you can use lithium titanium. Okay, and the good thing is it has a cycle life of 30,000 times. How many times can you charge a lithium-ion battery? 1,000 times. Some maybe 3,000, 5,000. Sometimes the manufacturer anyhow give a number, 5,000, 10,000. Because nobody is counting. And the best thing is when they count how many times you can charge and discharge, they only charge and discharge 20%. That means it's only 80% charge. 80% they charge up to 100%, and then they discharge to 80%, then they charge again, then discharge. They don't discharge fully, and then they do that, okay, 1,000 times. They assume that you don't use until flat. If you use your phone until it's flat, and then you charge until 100%, then you discharge, and then discharge fully, and then charge again, then you won't get 1,000 cycle. Or even if they put 5,000 cycle, you won't get it. So you get much less. So the number of cycle doesn't mean that you can discharge fully. It's only 20%. But for lithium titanium, it's not an issue. 30,000 times, you can do that for 100 years already. If one day charge and discharge one time, you can do that for 100 years. So it's normally like you buy this once and it will last forever. It's so fantastic. This battery is so fantastic. Okay, the dimension of battery is very big. So it is not suitable for a laptop or a phone or whatever. So it's more suitable for battery storage, like storage of energy in your house or as something else, whatever that you need to store and don't have to carry around most of the time. Okay, of course, you carry one piece around, still okay, but you get only 2.3 volt. So you need to carry two pieces to get 5 volt. Then you become like a USB power bank. Okay, and the other fantastic thing is that the discharging temperature, that means you can use the battery even below freezing point. So especially in countries where there's a winter snow. Okay, so if you use lithium ion and when it is below freezing, your battery cannot work. You try to use it, you can damage the battery. So for lithium titanium, if it's freezing point, you still can use it. Of course, not too low, until -20 only. So that will be useful for a car, let's say, parked under the snow. And then your battery cannot work. So Tesla car, if it's in the snow, it will not work. That's why they have insulation and they have a heater. So when there's a snow, the temperature drop too low, the battery will run the heater to heat up the battery, to keep the battery above freezing point. So you actually consume energy just to keep warm. Just like yourself, you got to burn energy to keep yourself warm. Okay. So one good thing is you can drill a hole right through. You can chop it into two pieces and it won't burn. Unlike lithium ion battery, it will not burn. But it costs, let's say, 2 times lithium iron phosphate. Okay, lithium iron phosphate battery and lithium ion are about the same price, similar. So in the long term, it's still better because 2 times and you get a cycle of 30,000 times cycle. Practically, you don't need to replace your battery. However, if you are using it for a car manufacturer to use this lithium titanate, I think they are not likely to use this because it will double the cost of the battery. So your battery is $50,000, become $100,000, and is a bit heavier than the lithium iron phosphate. So when you want to sell your car and your car costs 50,000 more than another car, for what? For a battery can last you 50 years. Your car lasts only 10 years only. In fact, the buyer of the car may be interested. After 5 years, he sells his car. The problem is the new buyer's problem. For the battery, for the car manufacturer, after 5 years, 7 years, if your battery got problem, cannot charge, or after full charge, cannot reach, they say 300 kilometers, maybe give you 100 kilometers. You want to change battery, can, you just pay for it because already warranty void already. No more warranty. Some car manufacturer will warranty the battery for a certain number of years or a certain number of charge and discharge. Depends how they want to do it. But if you have the money, you buy the lithium titanate, then you don't need to worry. It can last forever. Okay, so if you use a lithium battery, okay, for those who want to wire up your own battery, then you need to buy a battery balancer to balance the battery. And then you also need normally some electronics which will control the charging current limit and discharge current. Because if you discharge current too high, then the battery will heat up a lot. And then it can burn. Lithium ion will burn. Too hot, you start to burn. And then when you discharge too fast, dendrite will form. Dendrite. Later I explain to you what is dendrite. Okay, then that can cause a short circuit inside the battery. That will cause the battery to burn, catch fire. And you don't want that to happen when you are using it in somehow using it, and then the battery catch fire and then you can't run away, like in the lift or when you're sleeping, all this problem. And then when you are charging, make sure you have a voltage limit. You charge until full, you got cut off already. If you don't cut off, the electronics inside the battery must cut off for you. So if the electronics inside the battery didn't cut off, or you don't have any electronics to do a cut off, you must make sure the charging voltage is as a limit up to let's say if it's a 12-volt battery, it should be up to 14.4 volt, should stop already. You cannot go further. That's for lithium iron phosphate. For lithium ion, the voltage is different again. So all this you have to do your work or homework before you program, or just buy off the shelf. They really have the electronics to handle all this for you. So you don't need to worry so much.
The week to South Korea, check out Beng.
Okay. So when the battery runs too low, then you also must cut off. Let's say for a 12-volt battery, you run until 10 volt, you must stop already. Below 10, you have to stop, because if you don't stop, then the battery will get damaged. You cannot let the battery run like our alkaline battery, run until flat, then throw away. This one cannot. You run until the voltage too low, you must stop. So for those, let's say Tesla car, they put battery low, zero, is not exactly zero. There's still some energy inside, but they cannot use. If you continue to use, you can damage the battery. And your electronic must handle all these things. Okay, so you don't charge the battery in series without a balancer. This one earlier I explained already. Okay, this one means if you have individual battery, let's say you get 4 of the lithium battery to form a 12 volt. So you cannot put 4 batteries in series to get 12 volt. You must add a balancer. Okay, a balancer that balance 4 batteries together to get 12 volt. And the balancer for lithium ion and lithium iron phosphate are different. So when you want to buy, you make sure you buy the correct balancer for the right battery. Okay, but there are balancer that you can change, but those are a bit more expensive because it allow you to change the extra circuit inside. But if you buy those that fixed one, then it's cheaper. And if you have 2 12 volt lithium battery, you don't connect them in series. Okay, when you want to charge, you can charge them separately. That means you disconnect them and 12 volt, treat them like 12 volt, put them in parallel and charge it. Then both will get fully charged. Put them in series and treat them like a 24 volt battery and charge it. Then one will get fully charged, the other one will be undercharged. Because no 2 batteries are the same. So guarantee one will be fully charged, the other one will not be fully charged. And over time, the one that's not fully charged will get less and less charge. So it's not a good idea to connect like that. But if it's lead acid battery, you can just put 2 together, you can charge them in series. Okay, so the other danger is low temperature, which actually we don't experience like winter time or what. So it's okay. But if you go to tour, let's say you go Korea, go skiing, and you left your battery in the snow, then you pick up, you won't work already. You must warm it up, then it can work. Okay, then the most thing is overheat. You overheat, you can catch fire. That's why people even die when the battery overheat. And when you charge the battery, you charge it under the pillow or you charge it and then you fell asleep and the battery is covered by your pillow or covered by your body, and then you overheat and then you can get the problem. Some people will charge the battery in the pocket and the power bank is in another pocket. So the power bank charges the battery and the battery will overheat because your pocket, you have very little ventilation, all close up. Your body, your pants and all this. So the heat cannot dissipate fast enough and then it overheat. Of course, you can feel the heat on your pants, but sometimes you can't feel the heat because you put a casing some more. So the casing insulate the heat, so you may not feel it. So if you don't feel the heat, then you may overheat and then you can get into trouble. It burn inside your pocket by the time you realize it. Okay, so very common are the AA battery and the AAA. So this type of battery, if you want to migrate over from the old technology like a heavy duty or alkaline battery, you can consider this type of USB 5 volt charging battery. This type of battery is 1.5 volt, although the lithium battery is 3.7 volt. There are electronics inside there that will convert it to 1.5 volt. And then to charge, you just open up the cover, just plug to a USB. But if you use a USB-C, then you must find an adapter for USB-C to USB, then you can plug in. So if your battery flat, you can go MRT or in the aeroplane, sometimes they have charger, or some buses have charger, or hotel have all these USB charger. Just plug it in, you can charge your battery already. And if you want to buy a camera, you can buy a camera with AA battery, and then you use this type of charging. this type of battery, which is lithium battery, and the price is much cheaper than a camera with built-in lithium battery, with its own lithium battery. And that's expensive because once the lithium battery is damaged, and then or old or whatever reason, then you go back to the manufacturer to buy a new battery for your camera. It can cost you a lot. Or sometimes the battery obsolete already. The manufacturer don't even produce that battery, that shape. Then you cannot plug in already. Your camera has no battery, or you must find some way to improvise it. But if you use AA battery, you can always buy the lithium battery. You don't need to rely on the alkaline. And this side can last very long. You can take a few hundred photos. You put all this inside, very high power. The other side of the USB charging, you have a small hole there, which is a micro USB. Then you just plug the USB cable in and you can charge already. So this is another way, another method of USB connection to charge. So based on these two methods, the one on the right may contain a higher power. The one on the left may contain less power. But here you put there 5900 milliampere hour. Here is written here 3500 milliwatt hour. So it's a little bit confusing. Okay, so what's the difference of this 3500 milliwatt hour? Because if you consider this milliampere hour, if you multiply by the voltage, current by voltage, you get the power, which is watt. And it appears to be higher. But so far, my experience is it's not actually much higher. Some of these numbers can be fake ones. The reason is when you have such a big connector here, your active chemical is only that small only. You lose a lot of space. So you lose like 30% of the space already. 30% of space is used as a USB connector. So you have, your battery is actually 30% smaller. Whereas the other time, the electronics is on top. So you actually maybe lose 20% of the space for the electronics. Of course, they can always fill in less chemical, and then your battery got less power. So it's up to you lah. You buy and you try it out. Okay, here they put watt hour, here they put milliampere hour. Okay, so there's a difference. If you take this 3500 divide by 1.5 volt, then you get the milliampere hour. Okay, this one is recently I just saw this thing. This is quite a fantastic one because you don't need a USB anymore. You just take this battery, output is 1.5 volt because there's electronics inside to make sure it's 1.5 volt. And when you plug into a charger, the charger will charge at 4 volt, but the electronics inside will take the voltage, step down, and then charge your battery. So if you put in more voltage, it will start charging your battery. If you remove the voltage, and then this become a battery, it supply the power. So you don't even need a USB port already. And it has without the USB port, it actually can contain more power already. But somehow it's only written here 2800 milliwatt hour instead of the other one earlier here. You see it's 3500 and here is 5900. This I don't quite understand all these people. So someone must do a proper test and then decide. But I think this is quite good. Okay, because you just take this and plug it, but you need to buy this charger. The cost of this charger is very cheap, maybe a few dollars. But each of these battery is like $5, $6. So it is more expensive. Okay. Okay, this one is a lithium ion battery. Okay, but this one looks like a AA. Exactly same size as a AA. Sometimes the head are a bit flat. Sometimes there's something bulge out. Okay, but this one battery alone is 3.7 volt. Look carefully, 3.7 volt. This battery alone is 3.2 volt. Because this is lithium iron phosphate. This is lithium ion, so it's 3.7 volt. So if you put two of these together into your toy, your toy will burn. Because your toy requires 2 AA, which is 3 volt. And you put two of these, you'll be 7.4 volt. You'll just burn the electronics inside the toy. Or if it's a motor, the motor will run so far and overheat and also burn. Okay, you may not catch a fire, you just suddenly spoil already. So, but why are these batteries still around? Okay, these are created but without electronic circuit to step down the 3.7 volt to 1.5 volt. So it is intended for you to use one battery instead of two. Then the second one that you want to plug in is just a dummy, it's a short circuit. So you get very good power, and for the price of one. See, one of these is like $5. It's slightly cheaper than the one with electronics. And then you get 3.7 volt. Whereas the other one, you must buy two pieces, which will cost you $12. Here you buy one piece, $5. So $5 instead of $12. And then one dummy, maybe 20 cents. So the dummy is just a short circuit. It has no power. Okay, but this is a good one. But if you want to buy, you also can consider this one, 3.2 volt, which is closer to the alkaline battery. So a lot of electronics can work with 3.7 volt. Even my keyboard, I put one of these and one dummy, it will work. But some electronics may be a bit more sensitive. So you put this 3.7 volt, you can damage it. So I suggest you may want to consider this one at 3.2. This can be a bit more expensive, maybe $5.50, $6. A bit more expensive, but it's worth it because 3.2 volt. But once you have all this battery 3.7, 3.2, then you will have you must have a charger. Okay, I use this charger, little color. I have it, so I just plug it in and it charges by itself. It auto detect, it will charge. So if we fail to auto detect, because sometimes your battery voltage too low, very long didn't use for many months, and then the voltage discharge until too low, then it cannot recognize. Then you press this button to select which type of battery it is, and then you'll charge to that battery. If you normally you just plug in, you'll be able to detect whether is it lithium ion or lithium ion, and then you'll charge accordingly. It can also charge a nickel metal halide battery. And this one can charge a 18650 or the AA battery or AAA battery. You can charge any size battery and any voltage. Okay, of course, you cannot charge the USB type of charger. That one is not. You need USB to charge. You cannot use this one to charge. This one is meant for this type of battery. Okay, so when you buy, look at the voltage. Look at the voltage. Okay. Okay, so much about the portable battery. Now we look at the transportable. Transportable means it's quite heavy. Okay, and then it must not be liquid. If it's liquid, you flow here, flow there, and then you sometimes can short circuit or other problem. So it can be gel or solid. The people thought of solid state lithium battery, but until now, nothing happened. It looks like they have a problem getting it out, because whenever it's a solid, it's not able to conduct the ion flow. That's why they use a gel. Gel is still a little bit liquid, so they can flow. Okay, and then for transportable, you must have good energy to weight ratio, because you don't want to carry the weight around. The dead weight will cost you a lot of energy to move around. So you must have a good energy to weight ratio. Size bigger a bit is okay, because you just have less space, less sitting space. So it's still tolerable, but the weight is very important. So that's why they use lithium, because lithium is the lightest metal known. Nothing lighter than that. The next lighter one is hydrogen, but hydrogen is a gas, so another problem. And then it has to be, it need fast charging, because you don't want to spend 1 hour waiting for the charge. See, unless there's a karaoke nearby, while charging, you can go to karaoke. Then you can have need a lot of reinforcement against damage, because when you move around, you can knock on it. Let's say you put in a car, you're afraid of accident. So sometimes you talk about battery that is part of the frame. They call structural battery. So instead of having a structure like the casing, the door of your car, you make the door into a battery, or make a battery into a door. Then you don't need to have a space for the battery, because the battery is the door. The shape of the door is the battery. But there's a problem. Somebody bang your door, damage it, then your battery spoil. And some battery can catch fire. So you have a problem there. And when your door spoil, normally you go there, just knock a bit, okay already, or repaint a bit. But now if your door is a battery, then you got to change the battery. And change battery is very expensive. Especially yours is a custom-made door. A battery that look like your door, that is your door. So it's even more expensive. So normally battery, they hide somewhere. Normally it's at the bottom of the car. So nobody will knock your bottom. Unless they bang, they crash you, it knock the back, knock the front, knock the side, left, right, center, but not the bottom. So the battery at the bottom is safer, but you still need some reinforcement in case you go down the hump knock your battery, break into two, you catch fire. So, okay, you still need some reinforcement. So all these will add weight. And one more important thing is that you must try to get non-flammable, so that you don't burn inside your own car. Of course, currently they use lithium-ion battery, which can catch fire. But some use lithium-ion. Some use lithium titanate, which is safer. And the most important thing is it must not contain poisonous chemical. You don't want the battery to leak, and then you give out poisonous chemical, and then you die inside your own car. So these are very important. And of course, low cost. You must look for low cost, which that's why now they are trying to get rid of expensive metal, or they try to increase the production process so that the battery becomes cheaper. It can be cheaper by mass production, by better production process, or by cheaper material, or reduction of expensive material. Okay, and then it must have a moderate lifespan. You don't need your battery to last 20 years, 30 years. Maybe 7 years, 10 years are good enough. If spoil, they can come back. Or they can tolerate, instead of 300 kilometers, your full charge can last 100 kilometers. They still can use short distance, complain a bit, they still tong another 3 years, then they scrap the car, or they just throw away, change a new car. Okay, and then it must work at a room temperature. Okay, that one looks obvious to you, but of course battery can work at very high temperature also. Okay, so other candidates okay, there are lithium batteries coming soon without cobalt, no nickel. These are very expensive material. Nickel, they use it in your coin. So imagine you put your coin inside the battery. Wow. So cobalt is very controversial because it comes from Congo and a lot of they call blood cobalt or what. The abuse are a lot of abuse. They use small key and then they poison the mining of this cobalt, poison the river, poison the water table, poison the ground everywhere. Then a lot of people got sick, got problem. So cobalt mining is very dirty. And then they say bo jing hu. So whoever has the power control the cobalt, control the mines, cobalt mine. Okay, other candidates coming soon, the zinc air batteries. Zinc air battery has been around already, but it's expensive. One small battery can cost $3 compared to one large lithium battery, only $2. So zinc air battery is expensive. And there are some research saying you can have zinc air battery that is chargeable. I mean, research can say one thing, but 5 years later, you still don't see the result. Normally, zinc air battery is not rechargeable because when the zinc becomes zinc oxide, how you reverse it? Unless you have some other chemical that you can reverse it by applying a current in reverse, and then the oxygen disappears. It will knock out the oxygen again. Just like iron oxide, and iron oxide, you apply current and become iron. It's very difficult because this type of chemical is not a two-way one. Okay, and then aluminum air, everybody talk about air already now. Aluminum air battery, zinc air battery, because you don't need to carry the oxygen, so your battery become lighter. And then sodium ion, because sodium is very cheap everywhere, salt and all these things. And anything wrong, I just throw away the battery, is okay. Because salt, it's just like salt, table salt. You throw away a giam hu, giam neng, salted fish, salted egg. Nobody will charge you for disposing of salted egg. So the battery contains salt is okay. It's considered safe for disposal. And it's very cheap. So sodium ion will have a potential, but a lot are still research. You don't see all this battery coming out. Okay. Then iron is very cheap. Iron is very, so if you have iron oxide battery, then it's very cheap. It's like a piece of iron you use already, you can throw away. So this may be a one-time battery. But then it's okay for one-time battery because if you have a large, let's say a truck, you just run the truck there, then you swap the battery, you get a new battery, that's it. And then you can slowly charge your battery already, take your time, or send the battery to a factory to recycle. So the battery will cost more because every time you use one time, you got to dispose of. Or you can use it, let's say an aeroplane, a small airplane, and then it's lighter, then you can use it. So you don't need to charge already. You fly near there, you just change battery. Okay, of course, if you have a few battery for, let's say for a car or truck, you have a few of these, you just change those that are flat, you change. Then you have a new one, add in. So you may don't have to say, oh, I run only 50% now, to change or not to change. So this sort of thing can settle on. Same like zinc air, which is not rechargeable, or aluminum air, all these are not rechargeable. But research may make it chargeable, but not exactly zinc. Maybe some compound of zinc or aluminum. So in future, we'll see what's the research like. And the most important thing nowadays for battery is everybody is looking for cheap common mineral like zinc, aluminum, sodium, calcium, phosphate, phosphorus, sulfur, iron, all the cheap material. Even lithium is considered expensive already because lithium mine is not, there are not many, and the mining of lithium is expensive. Because just recently Tesla filed a patent how to extract lithium from the clay. Now it's very difficult. They got to use acid to extract the lithium out from the clay, and this acid will pollute the ground because the clay we have to dispose of together the acid, so the ground becomes acidic. But there's a new process whereby they will crush the clay until the lithium come out through some means. The details I don't quite understand how they do it. I don't also read the full paper of the patent, but it was said that actually Elon Musk already bought a mine already, a lithium mine with clay. People think it's not worth mining. So he has this technology, he go and buy the mine cheap. And now after he got the patent, he can mine the lithium from the clay. So quite clever, right? Okay, so the main problem with lithium battery is dendrite. Okay, so imagine the below is the lithium. So every time when you charge, then the lithium will be deposited at the bottom, and then slowly some may rise up. That's why you have a separator there to prevent the lithium from going over to the other side. Anode is a negative, cathode is a positive. So if the lithium reach the other side, it short circuit already. Instead of the current flowing from outside the circuit, now the current flow inside the battery. So it's just like you have a ground, and then you try to build your home higher and higher until you reach the sky. Once you reach the sky, the lightning come down and then burn everything. So that's why when you charge your battery, you cannot charge too fast. The faster you charge, the more dendrite you form, because you got no time to slowly pack nicely. So you charge slowly, then the chances of the lithium ion deposit evenly is higher. So if you charge too fast, the lithium may not have chance to deposit properly. It just stack one on top of the other, and then you form a path. That's why you call dendrite. Okay, so the separator is supposed to block, but the separator sometimes fail to block. It still penetrate through. So there's one technology where they have a heater in between the separator. So when they detect the dendrite, the heater will heat up and melt the lithium, so the lithium will fall back to the floor. So it will not touch it will not short circuit. So that's another technology. People talk a lot, but practically they don't use it because it's not so cost effective to have all these measures. So how to prevent dendrite? Now people talk about the nano this, nano that. Okay, for example, instead of having a layer of lithium, now they store lithium inside small little pockets. Okay, you can see the difference here, silicon, graphene, all this. I can't see the difference. I don't understand. But anyway, there's a structure to tell you. Okay, the structure start from here. Let's say if you charge the lithium come in, Okay, the lithium will not be pasted onto the plate now one by one. They have this structure to guide the lithium in. So once it's in, the lithium will pack inside this structure. So it will not form dendrite, less likely. So, but there's this problem as the lithium start packing in, the whole structure gets bigger and bigger. It's just like some of the things that absorb water, right? They use it to absorb water, and then once it absorb water, it becomes bigger and bigger size. Okay, so when it gets bigger, then you have a problem. Your casing will explode, it will crack, it will leak, and all these problems come in. So they need to have space for the thing to expand, so that when it expand and contract, it will not force a leak. These are technical issues that they need to overcome. If they can overcome, they can increase the storage at a much, improve the storage and improve the charging speed, and everything improve. So it's not just talk about battery, take two plates and put inside. Like in primary school, we learn about chemical batteries. The other problem is when the silicon structure expand and contract, it start to crack. Once it crack, then it lost its ability to hold all this lithium inside there already. So all these technical issue, engineering issue, chemical issue, whatever issue has to be resolved. It's not so easy. It's beyond our understanding. Unless we put our whole life there to learn all these things. And if you are successful, you will be a multi-millionaire already. You don't need to worry about your future. Okay, now we talk about fixed battery. Okay, fixed battery, the most important is the energy to cost ratio. It must be cheap for a certain amount of energy. Okay, that's the most important criteria. Okay, you don't care about the weight, you don't care about the size, because you are going to fix it on the floor or inside a building. Because the weight also matters, because weight will affect the shipping cost. But these are minor issues. The main thing is overall cost must be cheap. Okay, and the size may not matter because you may have a whole big desert for you to store your battery. And then the main thing, it must have a long life. So potential candidate is lithium titanate, long life, because it's normally fixed there. You buy a house 99 years, you're not going to change battery every 5 years, 10 years. It costs you another few $1,000s. So may as well you pay the cost, twice the cost, and for the next 30 years, 40 years, you don't need to care really. The battery will last that long. And you want to change battery is not easy. If you have a large scale, let's say a grid scale for your battery, or it's a lot of effort to move the thing around and all this. So they rather have a long life. Okay, and of course it must be environmentally friendly. Otherwise, a lot of people complain, hey, what happens, something, you get burned, then people within 5 kilometers all poison. Cannot. And then your battery leak, you poison the groundwater, people drink on the well, all these things all get problem. So it must be environmentally friendly. Okay, some of these battery are like liquid metal battery or the flow battery. Okay, some are transportable battery also, like you can use a lithium titanate or lithium iron phosphate, and then you can make it very, very big, the size of a container, and put it on the floor. Can be used. Okay, but of course, if you want to use lithium ion, you must be very careful. Otherwise, you catch fire, your whole container burn. And the smoke, or the neighbor will complain, hey, the smoke, no poison. Liquid metal battery is started from this fella, Don Sadoway, company called Embry, come from the Cambridge, Cambridge. So you just take the center word, called Embry. Okay, so to make the metal molten means to melt the metal, and you need 500 degrees C. So you heat up this whole piece, and then you get a metal anode, cathode, and then the electrolyte. It's a battery already. So you lock it inside the wall so that it will not, the heat will not get lost, stay inside there. And then the top plate is a positive, negative, and then the anode, cathode. Okay, one of them is the anode, cathode. So you look at here, okay, negative is the anode. Okay, here is a pure, they can use a pure magnesium, and then below you use a magnesium antimony alloy. So this is just an example. So when it's fully charged, you got a magnesium on top, then the salt, molten salt, and the antimony. So at room temperature, they are solid, no chemical reaction. Then you can ship it out in a container, no problem, because it's not a chemical, it's just a piece of metal, solid metal. So there's no chemical reaction, nothing. So there's no safety issue. So you can ship the whole container of battery at room temperature, just ship it out, no issue. So when you want to operate it, then you must have mechanism to heat it up to 500 degrees, and then it become molten or liquid, and then it start working. So when you use, the magnesium will react, and once the magnesium form with the salt, the magnesium will drop to the bottom. So you get magnesium antimony alloy. Then the bottom will go bigger and bigger until you discharge already. This one is discharge. Of course, you cannot over discharge. Then you touch the top contact, then you are in trouble already. So you only can discharge it there, and you understand that this is liquid, so you cannot put it in the ship. The ship will roll left, roll right, and then the thing will short circuit. The pure aluminum and the magnesium antimony alloy. So it's not suitable in a place where it will rock, or even you put in a bus, the bus not likely to rock so much. But what if the bus overturn, then the battery you'll get into trouble. But as long as it move, it start to rock, then it's not advisable. Right? So normally these are put stationary on the floor. Okay, and it's just it can be built as big as a container, and the material can be sourced locally. So they can source locally, construct the container, then put inside, put in the electronics, and then you got the battery. You don't need to ship all the way from the country. And these are very common minerals which you can build a factory in the country to produce the battery. So it's quite potential. But after 5 years, we only see pilot implementation here and there. And then people like Bill Gates invested in all these things. Okay, this is one of the Embry container. You open up, inside there are stacks of the battery. And then one stack you can see is a liquid metal inside. One cell. So you have many cells stacked together. Then you can increase the voltage. But imagine operating all this at 500 degrees. Sometimes people worry is the temperature, but to him it's not an issue, because as the battery run day and night, the temperature will maintain itself. It's not unlike lithium where you worry about, wow, too hot. The lithium battery will burn and damage the whole battery. But this one, hot, never mind. Hot is okay. Too hot also never mind, because it just melt. It's molten metal, so they are not afraid of heat. They are more afraid of not enough heat. Then the metal becomes solid. Then it stops working. So it's a different worry. They worry not enough heat. Because lithium battery, they worry too much heat. So not enough heat is not a big issue, because they can insulate it properly. Once you insulate it, then there's very little heat loss. You can maintain the heat. So this type of thing is only for very large scale where you have the skill and to handle all these things. Okay, so there's a future, all these are under research. When people talk about it, maybe 5 years later, you also don't see the thing come up. So this one is room temperature metal, some sort of compound, sodium, potassium liquid. It becomes liquid at room temperature. The only metal we know that's liquid at room temperature is mercury. But mercury is very heavy and expensive and it's poisonous. So you use it as a battery is not suitable. The other one is gallium. Gallium, if you put your finger and hold it, this metal will melt under the heat of your finger. It's so fantastic. So it is a very low melting point. Okay, flow battery is the same like lithium battery, except that instead of using a gel inside the lithium battery, they use liquid. So when there's a when the electrodes get consumed, then you just pump in more liquid. So forever full one. So this battery can run very long. It has very high storage. You just need a pump, keep on pumping in. So you can have a tank. How big is your tank means how big is the battery. But of course, one battery is still 3.7 volt. So you need many batteries, depending how many volt you want, and many tanks. Of course, you can have a big tank, one tank to pump into 8 batteries or 16 battery and so on. So you keep pumping in. So in this way, you can run almost the battery storage is very simple. You just pump inside. Not like you want to construct a lithium battery, you need to have a long sheets of electrode and electrolyte to roll them up into a battery. You just here just pump inside. But it appears to be easy, so we assume that it could be cheap. But so far, they are not cheap. They are sometimes more costly. That is more costly than a lithium iron phosphate battery of the same capacity. Don't know why. This type of technology and the battery is more expensive. Okay, so we shall end here. Thank you, everybody. How come I stopped recording but it doesn't?